Have you ever had an especially vivid dream? Such dreams have raised questions for some of history's great thinkers, like the famous anecdote of an ancient philosopher who dreamed he was a butterfly, but upon waking, wondered if he might instead be a butterfly dreaming it was a man. How do we trust our perceptions when dreams can make us doubt our senses? How do we know what is real when we can dream intensely of a life not lived and wonders that don't exist anywhere in the world? Technology increasingly enables us to bring the expansiveness of dreaming to the waking world. But how close are we to creating an experience that would raise questions for those old philosophers? This is ASU. In virtual reality, or VR, we replace a user's sensory experience in the physical world with stimuli that represent a virtual world. In augmented reality, or AR, we digitally insert virtual objects alongside physical objects. In both of these, we're fusing virtual experiences with physical experiences, bridging these virtual and physical realities together. Game engines let developers create content, and when running the applications, the game engine will render that virtual content, especially the visuals and audio that a moving virtual camera sees in the virtual scene. The crux behind VR and AR is in estimating the device's pose, where it's located and where it's pointed. VR and AR frameworks use that pose to update the game engine's virtual camera so that movement in the physical world corresponds to corresponding motion in the virtual world. The devices then output the rendered game engine visuals through screen displays and lenses that properly feed the image into the user's eyes. So as the user's head or their phone moves around, the virtual camera moves with it and the visuals update. However, it's very important that the motion tracking, the visual rendering, and the display output is done as swiftly as possible. If the user moves their head and the display is slow to update moving later, then this can cause motion sickness, especially in virtual reality. Researchers measure motion to photon latency, counting the time between the motion when the head moves and the photons when the displayed light photons account for the updated position. Device manufacturers do everything they can to bring motion to photon latency as low as possible, aiming to be less than 10 milliseconds from head movement to display update. However, when done properly, VR systems create the illusion that VR users are moving around in a virtual world the same way they would be moving around in a physical world. AR systems likewise provide the illusion that AR virtual objects belong right there among your physical world's objects. Through some clever coordination of tracking and rendering, our systems can fuse these virtual and physical worlds together. By continuing to improve our approaches to bridging physical reality and digital worlds, we can allow VR and AR users to explore new questions. Just as a philosopher dreaming of being a butterfly over 1,200 years ago, VR and AR raises questions that change the way people think about consciousness and perception. Who knows? One day we may build virtual worlds that even make us question our own perceptions. This was ASU. Thanks for watching.